Here we have an example for calorimetry. In an experiment, a 0.20 kg of insulated aluminum can contains 300 grams of water at 25.0 degrees Celsius. The can and the water are in thermal equilibrium. Then a 0.10 kg metal block whose temperature is 80 degrees Celsius is placed in the water quickly. It is then covered immediately to avoid heat loss. Using the thermometer, the final temperature of the can, water, and block is at 30 degrees Celsius. Determine the specific heat of the metal block. Here we write the given values based on the problem and its conditions. We draw the problem and see that there are three quantities that interact by exchanging heat. We then write the equation for the conservation of heat energy. These three quantities are the Q from the aluminium can, the Q from the water, and the Q from the metal block which has a higher temperature compared to the can and water. So, we can imagine that this one will lose heat and the other two quantities will gain heat. We then write the equation corresponding to these quantities and rewrite it to solve for the specific heat capacity of the unknown metal. We get that the value of the specific heat capacity is 1439 joules per kilogram Kelvin.